In this video lecture, we are going to discuss about one important topic in third unit, min-max algorithm. This is mainly used in any game playing where decision making is involved. We'll move on to the next slide to see more details regarding this. This is one such strategy in constraint satisfaction problem. This is one of the algorithm in constraint satisfaction problem where the constraint is you are playing a game based on certain rules. For example, chess. And this is the algorithm. At the terminal node, there are certain some values given for each and every node, and at each and every level there will be a values given. For example, A is the maximizer, B, C will be the minimizer, D, E, F, G is going to be the maximizer, and at the root level, that there is the bottom level, sorry, leaf level, that are called as terminal, you will be having the values. These values can be negative or positive. If it is negative, we say it is minimum, and if it is maximum, we say it is positive. The meaning is there are two players in this particular game. One player is going to win the game, that is the maximum player, and the second player is going to be the minimum player who is going to lose the game. So the value for the minimum player can be negative, and value for the maximum player may be positive. It will be definitely positive. So these are the two things which you have to understand. And when we assume this is going to be the graph, it can be processed step by step. For example, here at H it is negative value, and at I it is positive value, and at this top level of this at D and E it is going to do the maximizer. So we take the value 4. So that is given in the next step. Similarly, we proceed at this particular level and complete this particular step 2. Now, based on this, we go to the next step, step 3, and here at D and E we have 4 and 6, and the role of this is going to perform minimizer. The role of B and C is going to perform minimizer. So for 4 and 6, the minimizer is 4. So like this, we fill this way, and finally we reach the root where we find out the final value. With this value indicates the optimal value in which the solution can be found. So this is how your min-max algorithm is going to work. This is pretty simple, just numerical calculations only based on understanding. And these are general properties of your min-max algorithm. It is complete. It produces you an optimal solution in a certain time limit. Time complexity of it is in order of b power m, where m is the number of branching factors, b is the number of branches, and m is going to be the maximum depth, and space complexity order of b into m. And the drawback of this algorithm is going to be then more the number of branching, it becomes very complex. That is the drawback of this particular algorithm. Thank you.